The last section that we're going to talk about in Chapter 5 gets back into talking about some complex number stuff again. Imaginary numbers, complex numbers, stuff like that. Now, the initial part of this assignment really isn't terribly difficult. We're going to talk about how you could graph complex numbers, which should give you a better idea of why you happen to see parabolas sometimes just kind of hanging out with their vertex in the middle of nowhere, and they don't intersect the x-axis anywhere. And then we're going to get into some adding and subtracting, some multiplying, and even some dividing of complex numbers a little bit. Okay, so some key words that we're going to talk about. We're going to talk about the complex plane, which basically is just kind of an extension of the XY coordinate grid, and kind of gives us an idea of how we can graph complex numbers. And then the other thing we're going to talk about is if you have a complex number that you're graphing, you still want to be able to tell the absolute value of it, or basically how far it is from the origin, or how far its distance is from zero. And essentially, the absolute value of a complex number just turns into using a little bit of what looks like the Pythagorean theorem to find the distance that we're talking about there. Alright, now, just like you can represent numbers graphically on a number line, you can also take complex numbers and you can represent them, but you need a coordinate plane to do so. Okay, and in this case, it's kind of a special coordinate plane because we're not necessarily talking about an x and y axis. We're talking more about a real number axis and a imaginary axis. Okay, well, in this case here, the horizontal axis is going to represent the real numbers, and the vertical axis is going to represent the imaginary numbers. Alright, now this might sound a little bit complicated. It's really not that difficult. Okay, so if we're taking numbers that are in the form a plus bi, essentially what we're going to do is we're going to move left and right according to whatever our real number is, and then up or down according to whatever the number in front of the I is, or whatever the imaginary number is. Okay, so at the bottom here, this is kind of a helpful hint. If you want to think about a plus bi as x plus yi, if you'd like to make that comparison between the complex plane and the regular coordinate grid and coordinate axis, you could do that if you wanted to. Alright, so we're just going to kind of jump right into this. So if I take a up here, which is 2 minus 3i, I'm going to go 2 in a positive direction, and I'm going to go down 3, negative 3i. So I would be down here somewhere. Okay, so again, positive 2 this way, negative 3i, down to that one there. Okay, b, negative 1 plus 4i. So we're going to go over 1, and we're going to go up 1, 2, 3, 4. So that one would be plotted right there. So this is b up here. This is a down here. Now, obviously, you don't have to draw the lines in there. I'm just kind of using them a little bit so you can track how I'm getting these numbers to where they're supposed to be. All right, c is 4 plus i. So we're actually going to go all the way over 4. And then plus I means plus 1i. So we're just going to go up there. So that would be c. All right, and the last one, d, just says negative I. All right, well, if there's no real number part to it, we don't move left or right at all. We would just go from the origin down 1, because negative I means negative 1i. So that would be d. So I have plotted all those numbers in the complex plane. All right, now that we have that done, this kind of leads me to my next point where we're going to talk about absolute value. In some cases, we still want to figure out how far a particular point is from the origin, or is from 0. Okay, so if I look at all of these, all right, if I look at C over here, the actual distance it would be from 0 is represented by that dotted line. Same thing with B. Okay, so you'll notice these kind of start to look like triangles, right? Well, if you think back to Pythagorean theorem, if you want to think about this dotted line as the hypotenuse of those triangles, all right, if you take the real part squared plus the imaginary part squared and take the square root of that, it'll tell you what that distance is that I labeled h, or essentially it'll tell you what the hypotenuse is, or the straight line distance, or absolute value in this case, distance from 0 that particular point happens to be. Okay, now this next slide helps to kind of outline that idea a little bit better. Okay, it's just showing pretty much what I showed on the last slide over here in this particular corner. Okay, if you take the real part, square it, and you add it to the imaginary part, and with the imaginary part we're just talking about the number in front of the I, okay, not the I itself. Alright, so you take those numbers, you square them, and you get what the absolute value would happen to be. Alright, so for example here real quick, if I have 3 plus 2i and I want to find the absolute value of that, I'm just going to think about what's written right here. Alright, absolute value bars around it. I'm going to take the real part, which is 3, and square it. And I'm going to take the imaginary part. Now again, it's just the number in front of the I. Do not include the I underneath there. You're going to mess everything up. Okay? So that number is 2. I would square it, and then I would take the square root of those. Alright, so essentially I have the square root of 9 plus 4, which happens to be the square root of 13. Now you can't do anything with that, so the square root of 13 would be the absolute value of that expression I have written at the top. Alright, now on the next page here, next slide, I got a couple more examples. Now the first one, A, is very similar to what we did before, or what I just did, so I'm not going to go over that one again. But I'm going to look at this B here. Now you'll notice I have a real part, but I do not have an imaginary part. Okay, there's no I, so I'm going to put a 0 there. Now I always fill that in just because it helps me. You don't have to if it's not there, but just don't get confused. Alright, so what I'm looking at now is basically whatever happens when I take negative 13 and square it, I get positive 169. Okay, and you can actually take the square root of 169, which would be 13. Alright, so the absolute value of this is just 13. Now that makes sense, doesn't it? Because if there's no I part in there, essentially if you just take the absolute value of the real number part, the absolute value of negative 13 should just be positive 13. So I showed all the work here, but essentially I could have just thought about it as an absolute value like before. Now, this part here with the I is going to work in a similar fashion. I don't have a real part, so I'm going to put 0 squared. And over here, I have negative 7 squared. And technically over here, I probably should have wrote that in parentheses too, because you should always get positive numbers underneath these. Okay, well, essentially, this results in the square root of 49, which is just 7. Alright, so the absolute value of negative 7i is just 7. Kind of basically for the same reason that we got 13 over here. If you don't have both parts, you can kind of just think about them as the absolute value of an ordinary number. Okay, the same would apply. You know, say I was taking the absolute value of negative 22i. All right, well, because I don't have a real part, just think about basically what's the absolute value of 20 or negative 22. It's positive 22. You don't have to do a whole lot of work. So really, the only time that you have to do a lot of writing everything out would be if you actually have a real number part and an imaginary part. Just remember again, when you square those numbers, the A and the B, do not include the I in there, because the I is just going to mess everything up. It's only the number, it's only the real number part and the number that's in front of the I. Alright, now, the next part, and this kind of just explains what's going on here, as far as we're going to add and subtract a little bit. Okay, now adding and subtracting complex numbers is very similar to adding and subtracting variable expressions. All right, so essentially what you want to do is you just want to kind of think about the I in a similar fashion to the way that you would think about a variable, like an x. You can only put terms with x's together when you add or subtract. Likewise, you can only put terms with i's together when you add or subtract. Okay. All this is saying up here is to just kind of give you a little heads up to the fact that when we start subtracting complex numbers, we don't really ever subtract. We just add the opposite or add the inverse. It makes things a lot easier. So I'm going to start with something like this. And like I said, it's relatively simple. I take the real number parts and I combine them. I take the imaginary number parts and I combine them. So in this case, I'm looking for 4 plus negative 6 would be negative 2, and 2i plus negative 7i would be negative 5i. Boom. There's your answer. All right. Not a whole lot to it. Pretty general arithmetic, adding and subtracting. All right. Same idea here, but we're subtracting. So what the first thing I'm going to do is I'm going to take and I'm going to change it to a plus sign, and then I'm going to change the signs of everything else inside there. Okay. We're going to add the opposite or add the inverse. All right. Now I go about it just like I did the last problem. 5 plus 2 is 7. Negative 2i plus 3i is plus I. Okay? Again, make sure your answers are written in standard form, or basically in the A plus BI form. Okay? Real number part first, imaginary number part second. Alright, now there is another way that you can add these kind of graphically. I'm going to show you. You might have a little aspect to this on your assignment. Okay? But really all it is just kind of showing when you're adding these together just a different way you can get your solution. So if I'm looking at the parts that are graphed here, essentially if I were to take these red lines that are there and kind of mirror them and basically kind of go from here to here, I kind of made that shape, or I kind of completed that rectangle a little bit. And the point that happens to be right here, which would be 5 plus 2i, that happens to be the solution you would get if you'd add these together. Now if we think about it, if I start with this point up here, and I look at the other point down here, if I go 3 minus I, so over here, I'll kind of draw this in here. If I go over here 3 and then down 1i, I get to this point. All right. If I look at this point down here now, if I were to go plus 2, plus 2 this way, and then go up 3i, I would get to that same point. Now all that's doing is confirming that the point 5 plus 2i is a solution to this. And we could check it real quick and just combine parts. I get the same thing when I do the work there. So that's just a way of kind of using geometry to come up with a solution to these. Okay? If you can come up with the point that basically finishes your geometrical figure, in this case a rectangle, that point is going to be the solution. Or you can kind of count, using the other point to get to that point itself, so you can tell what's going on. All right, now we're going to multiply. All right, now multiplying, again, is similar to addition and subtraction in the fact that you're just going to multiply and treat the i's like they're variable terms. The one thing you have to keep in mind is that when you get I squared actually equals negative 1. And if you think about it, if I is the square root of negative 1, if you were to go ahead and square both sides, I squared would equal negative 1. Okay? So we can use that, so you're never ever going to leave an I squared in a solution. Okay? You're always going to change it to negative 1. Or essentially, if you get an I squared, it's going to be like almost just kind of changing the sign on that particular term, or multiplying it by a negative 1. So if I look at something like this, I'm just going to distribute. Okay? Negative 4i plus 8i squared. Now, like I said before, I squared is just like negative 1. Alright, so I'm going to treat it that way. So I get this, and then to write it in standard form, I go negative 8 minus 4i. Real number part first. Now what you can see is I'm going to fill in negative 1 so you can see them as we go. But essentially, when you get this I squared here, all it's going to do is it's going to change the sign that happens to be in front of that particular value. Okay? So these are kind of some of those that you'll get used to a little bit more as you move forward and go with this. Alright, now here, again, we're going to treat the i's just kind of like they're variables to begin with. Now in this case, I'm going to FOIL. So I'm going to get 12 there, negative 3i plus 24i minus 6i squared. Alright, so we'll do a little kind of consolidating here, combining. Alright, so plus 21i minus 6i squared. Now, like I said before, this is essentially like having minus 6 times minus 1. So really all it's doing is it's taking and it's changing that sign and making it a plus. Alright, so 12 plus 21i plus 6. Now I can combine the 12 and the 6, so I'm going to end up with 18 plus 21i. Alright, again, the process really isn't that much different than when we were multiplying binomials or distributing and we end up with x squared. The difference is when you get an I squared, you have to represent it as -1 and essentially change the sign of the number that happened to come in front of it. Alright, similar fashion here, and you should notice the pattern that's going on here. Essentially, this kind of looks like a difference of squares. I have the same numbers or terms in each parenthesis, in each binomial, but they have a different sign between them. Now I'll do the full FOILing process. 4, I'm going to get minus 18i plus 18i minus 81i squared. Now you can see because you have different signs and you have a difference of squares, these terms in the middle are basically going to cancel each other out. So I'm going to end up with 4, and remember this I squared is just going to change that sign, so it ends up being plus 81. Alright, so I end up with 85 as my answer. Now the whole idea there with the same terms but different signs between them, the whole difference of squares ideas, that's going to come into play with one of the last things we do here when we start dividing a little bit. And you'll want to think back to when we were finding the complex conjugate a few lessons ago, because we're going to use the complex conjugate to essentially set something up that looks like this. Because when we set something up that looks like that, you'll notice how the I terms cancel each other out. So the resulting solution is just a real number. We don't have any imaginary parts to it anymore. Alright, last one here. If I'm just multiplying these two together, I'm going to get negative 30i squared. Again, we can think about the I squared as a -1. So essentially, I'm just going to get 30. No imaginary part again, because I basically just have two imaginary numbers being multiplied together, which results in a real number solution. Okay, second to last thing here. Sometimes things can be represented with higher powers. I's can be represented with higher powers. Now, the one thing I want you to keep in mind here is we've already talked about I. If we take I squared, we get -1. If you were to take I to the third, essentially it's like taking I squared times I, so we get back to that -I. And then if you take I to the fourth, essentially you end up with -1 times -1, which gives you 1. Alright, so we're going to want to really keep in mind this and this right here, because that's going to help us simplify things that are a little bit larger. Okay, so what we're going to do is essentially when you do these, you can kind of see the pattern here. Your answers are either going to be I, -I, -1, or +1. Okay, now there's a couple different ways you can go about thinking about this. I'm going to do it this way, and you can refer back to that chart if you want to. Now I'm going to just, in this case, forget about the 6 there for a second. I'm going to focus on the I to the 14th. Now I think the easiest way to remember this is I to the 4th is 1. So essentially I'm going to take this exponent here, this 14, and I'm going to divide it by 4. Alright, or I'm going to think about it this way. I to the 4th times I to the 4th times I to the 4th would give me I to the 12th. And that means I'd have an extra I squared left over. Well, I to the 4th is just equal to 1 all the time. So basically getting rid of those, I can almost think about what I have here as -6i squared, because all these 1's are just going to cancel each other out, or basically 1 times 1 times 1 just gives me 1. Alright, so if I have negative 6 times I squared, essentially I have negative 6 times negative 1, which is give me positive 6. Okay, so I think, like I said before, the best way to think about it is think in terms of 4s. All right, kind of go back, almost kind of like to what you talked about in elementary, as far as we're going to take, like in this case, 63, and we're going to divide it by 4. Well, 63 can be divided by 4 15 times, which would leave me with 3 left over. All right, so essentially, if I want to think about it this way, so 15 times 4 would give me 60. All right, so basically I to the 60th times I to the 3rd. Now I to the 60th is just made up of multiple different versions of I to the 4th. So I to the 60th, because it's all just I to the 4ths being multiplied by each other, is just equal to 1. All right, so essentially we don't even need to worry about those. So I just have I to the 3rd. All right, well, we can think about I to the 3rd as I squared times I. Well, we already said I squared is negative 1 times I. We get negative I for our answer here. Okay, now again, when you're doing these, you just want to remember, you're either going to get 1, negative 1, I, or negative I. Those are the only possible answers you can get when you're simplifying an I that's raised to a power. Now, if there's another number out front, all right, you would just take whatever you get and multiply by that number. For example, if this started out as negative 2I to the 63rd, all right, well, I would just take this answer from I to the 63rd, all right, and put a 2 in front, all right, or take that negative 2 times it, and I would actually get 2I in this case. All right, so once you convert it, it's just some basic algebra from there if you have a number or a coefficient on your I. All right, now last thing. This is where we're going to use the complex conjugate. Now essentially what we're doing here is we are just dividing. Okay, but if you remember, I represents a square root, and we can't leave square roots on the bottom of fractions. It's a no-no in math. All right, so what we have to do is we have to what is called rationalizing the denominator. Okay, or essentially rationalizing the denominator means you got to get that radical out of the denominator, or in this case, get the I out of there. So what we're going to do to rationalize these is we're just going to multiply each expression by the complex conjugate over itself. Okay, remember, complex conjugate, you just change the sign in front of the imaginary part of the expression. All right, so in this case here, what I'm going to do is on the top, I'm going to distribute. So I'm going to get negative 15I minus 50I squared. And on the bottom, I'm going to get negative 25I squared. All right, now again, the whole idea here is I technically represents a square root. You cannot leave a square root on the bottom of a fraction. So we rationalize by multiplying by the complex conjugate, which essentially in this case gives us an I squared on the bottom. All right, and that I squared gets rid of any i's that we would have, so we no longer have an issue on the bottom. So I squared is negative 1. I'm going to take that negative 1 times that negative sign that's up front, so I'm just going to get 25 on the bottom. Okay, on the top, all right, this I squared is going to take and it's going to make this sign positive. All right, so 50 is going to be my real part, minus 15I is going to be my imaginary part. Now, I'm not done yet. We have to think about this similar to the way that we thought about square roots when we were using the quadratic formula. 50, 15, and 25 are all divisible by 5. All right, so 10 minus 3I over 5. All right, now I'm going to write it this way. Now, you can leave that as your answer, that's fine. Or, because both terms on top are divided by the same thing, I can essentially take 10 divided by 5, which is 2, minus 3I over 5. Or take both of those parts and divide them by the denominator. Now, sometimes, like I said, multiple choice questions on quizzes, you might have something like this that's an answer as an option for multiple choice. So you need to know how to get from one form to the other. Otherwise, you might mistakenly not mark something that you should mark as a correct answer. All right, now, here, this is a little more typical of what you're going to see. We're going to multiply by the complex conjugate again, which is going to be 4 plus 2i over 4 plus 2i. Now remember, we put it over itself because essentially this whole expression right here is equal to 1. If something's equal to 1 and we multiply by it, we haven't changed the value of the expression there. We've just put ourselves in a position to represent it in a different way. Now you'll notice on the bottom how it looks like a difference of squares set up here. All right, different signs between them, so we know that the i's are going to cancel out. Now before we get to that, on the top we're going to have to distribute. So 2 times 4 is 8. 2 times 2i is going to be plus 4i. 8i times 4 is going to be plus 32i. And 8i plus 2i is going to be plus 16i. Right on the bottom. Now we talked about this. We can go through the whole process of FOILing. So 16 minus 8i plus 8i minus 4i squared. Or you can realize that because these middle parts are going to cancel each other out all the time, you only have to do the first terms and the last terms as long as you have the exact same expression with a different sign between them. That's how difference of squares work. All right? So that just leaves me with 16 minus 4i squared on the bottom. All right, now time to combine and simplify a little bit. I squared is going to change that sign because it's equal to negative 1. So essentially I'm going to end up with 16 plus 4 on the bottom, which is just going to be 20. On the top, all right, and this should have been 16i squared. Sorry about that. Okay, well in that case, the I squared is going to change this to a negative, so I'm going to have 8 minus 16, which is going to be negative 8, that's my real part, plus 36i. Now again, we have to look and see, can we simplify it all? It looks like all of these are divisible by 4. Divide this by 4, we get negative 2. Divide this by 4, we get 9i. Divide this by 4, we get 5. So negative 2 plus 9i over 5. That's one way you could represent your solution. The other way would be to say negative 2 fifths plus 9i over 5. That is the other way if you were to take both of those and divide them by the denominator. Now, I realize that I threw a lot of information at you in a relatively short period of time. All right? There's not really a whole lot to this, okay? The adding, subtracting, multiplying, all that stuff, very similar in nature to all the basic operations of that sort that we've done before in the past. Okay? The conjugate stuff is a little bit new, but if you follow along with those examples that I showed you there, that should be relatively easy too, because the setup is a little bit new, but the actual operations are very similar to everything that we've done up to this point in time. All right, just like always, if you have questions about anything, please make sure that you ask. Otherwise, make sure you get a good head start on everything and come to class with, you should be able to get the majority of your assignment done prior to us meeting.